Welcome back to our web application penetration testing series. Today we are looking at how to bypass client-side restrictions. The core vulnerability we are exploring is how browsers generally allow us to pause, intercept, and edit data right before it gets submitted to an application's database. Our goal is to catch data leaving the shopping cart, hold it in a temporary limbo space to alter the price tag, and deposit that forged data into the server's database to purchase a TV for a fraction of its cost. Let's set up our environment. Log into your WebGoat suite, navigate to the Client-Side Attacks menu, click on HTML tampering, and select Lesson 2. You do not need any specialized third-party hacking software for this. Everything required is already built into your standard modern web browser. This entire attack relies entirely on exploiting the system's blind trust in the data the browser sends it. Step 1 is establishing our baseline. Enter a quantity for the TV and click the Checkout button to attempt the purchase normally. The application immediately rejects the request, displaying a message stating the item is too expensive and that you need to buy at a cheaper cost. This transaction failed because the browser natively submitted the unedited full price total straight to the server. To intercept this process, we need to access the raw data before it leaves your machine by opening the browser's network developer tools. You can pull this up quickly using the keyboard shortcut shown here, Ctrl-Shift-E. When you open this tab, you will likely see a highly cluttered network log. Leaving this full masks our target data and makes it difficult to work, so explicitly clear the network log. Click the trash can icon or the clear symbol, depending on your specific browser, to create a clean slate. Establishing this clean slate is essential. It isolates the exact transaction packet we intend to manipulate, removing any guesswork. With the empty network tab actively recording, click the Checkout button on the web page one more time. Direct your attention to the bottom panel. You will see a single new task populate in the network log. There are two crucial identifiers we must verify here. The first is the post method. This indicates that data is actively being pushed from your machine to the server. The second identifier is the 200 status code, which confirms the server successfully received our communication. Click directly on this specific post request to open up its detailed breakdown. We have successfully paused the data packet in plain sight, laying bare the specific parameters the application expects to receive. Now, right-click the captured post request on the left-hand panel and select the Edit and Resend command. Ignore the request header section entirely. Scroll down specifically to locate the request body. Inside the request body, you can see two specific parameters exposed: QTY, which stands for quantity, and total. Highlight the existing numerical value assigned to the total parameter and delete it entirely. As you can see in this mockup, we are going to type our new discounted payload value right into that slot, $29.99. Click the Send button to fire the alter counted back to the server. Locate the brand new task that just appeared at the very bottom of your network list and double-click it. Look at the server's new response feedback message. Well done, you just bought a TV at a discount. The server accepted the tampered price as truth simply because the browser handed it over, completing the exploit. You have just successfully executed a transaction manipulation, and you did it entirely manually. The architectural lesson behind this exploit is clear. Web applications are inherently vulnerable if they implicitly trust data arriving from the client side. The necessary defense against this tampering is server-side validation. The rogue $29.99 payload travels to the server, cross-referenced against an internal secure database containing the actual price. The server detects the mismatch and immediately blocks the transaction from completing. If you encountered any issues during this lesson or have questions regarding the developer tools workflow, feel free to leave a comment below. Remember to like, share, and subscribe to stay updated on future cybersecurity tutorials. Understanding how the attack works is the first step to building secure systems. Thanks for watching.